Hey guys, it's Mr. Wicklehouse, and today, on top of doing the review for the test, I'm going to talk to you about one really simple concept, and that's finding the ratios of sides, areas, and volumes given one of these pieces of information. Okay, this is not that hard, pretty straightforward. It's a pretty simple idea. So given the ratio of the sides of a figure, find the ratio of the area and the volume. Okay. Now I don't know if you guys have ever thought about this before, but we know that we measure sides in let's say feet. So we're measuring something in feet. Well, if you're laying tile or something, then you start thinking about the area, and when we talk about area of figures, we bring that up to feet squared. So you may have heard like area of a carpet or area of a tile or whatever given in feet squared, because we need to know how much we need to lay on the floor, and that's rectangular and that's area. Volume on the other hand is one step higher than that. So instead of feet and feet squared, volume would be another dimension higher, which would be feet cubed. Okay? So all we're going to do for this, so they gave us the ratio of the lengths of the sides is 1 to 2. So then the ratio of the area, all I'm going to do is square each one of these numbers. So I do 1 squared to 2 squared. So the ratio of the areas is 1 to 4. Pretty simple. If I'm looking for the ratio of the volume, then ratio of volume, instead of squaring it, I'm going to go one higher and I'm going to cube it. So 1 cubed, 2 cubed. That's going to be 1 to 8. That's all we're doing. Given the length of the sides as a ratio, the ratio of the sides, we just square the ratio to get the area and cube it to get the volume. Okay? Do a couple more little things. Okay. This one's a little bit more complicated, but not really that bad. So given the ratio of the area, what is the ratio of the sides and volume? Well, here's the ratio of the area, and that's 425. So I know that that's given me the area, the ratio in terms of some number squared. Went out of focus there. See if we can get it back in here. There we go. So now that I'm thinking about this in terms of some number squared, all I need to do is think, what number squared gives me 4? And what number squared gives me 25? Okay, well, all we have to do is take the square root of 4 and the square root of 25, which then gives me square root of 4 is 2, square root of 25 is 5. So here's the ratio of the sides. It's 2 to 5. Always go back and try to find the ratio of the sides first. After you find the ratio of the sides, everything else falls into place, because we know that the ratio of the volumes is just these cubed. So it's 2 cubed to 5 cubed, which is equal to 8 and 125. So there's the ratio of the volumes. Okay. One more. Ratio of the volume is given 27 and 216. Well, similar to what I did with the square ones, I know that some number cubed is 27 and some number cubed is 216. Well, all I have to do then is take the cubed root of each one of those, and you may not know those off the top of your head, but lucky for us, we could go into our nice handy dandy calculator and figure out what the cube root is. So if I go in here, I can see 1, 2, 3, 4 down is going to give me the cubed root. Cubed root of 27 is going to be 3. And we'll do the same thing. Go to math here. Go down to cubed root. And go to 216. And the cubed root of 216 is 6. So my ratio of my sides now I know is equal to 3 to 6. Now how do I find the ratio of the area? And I hope you're saying square this number and square this number, because then you'd be absolutely right. And that's going to be 9 to 36. That's all there is to it, guys. And I'll talk to you later.